You can see what do you reckon we're going to set to you here? So really we want to get rid of the whole bracket. So we want the whole bracket to be U. So the du dx, and if I shortcut it, I'm going to multiply by the dx. I would like you to then put that so you can see exactly what we're going to swap over. So that's just rewriting. Then I'm going to substitute. That's going to be u to the fifth, and that's going to be du, which is going to be u to the 5 plus 1 on 5 plus 1. And u is x cubed minus 3. And
plus c.
Plus c. That c is just the last tag over, isn't it?
Yeah.
You can see the relationship here. So set u equals x to the 4. And then actually write that out as a line. Don't skip it like me. I'm just saving in the room. So you can see me aligning that for my communication so it makes sense. So that's going to be e to the u, du. What's the equal of e to the u? E to the u. And u is so they're pretty straightforward. You just got to get the substitution right. U equals sine. Because du dx will equal cos x dx, so the integral will equal which is sine x. Straightforward, nice and easy. You just got to spot it. Practice will be right. Okay. We've got to get rid of our denominator. So if you think about it, it's the bracket that's the issue. There are brackets there, aren't there? Just like over here, the brackets were the issue. We want to get rid of the whole bracket. So I know I'm going to have to set. So du dx equals 3. So I want a 3 dx, not a 2 dx. So when I rewrite it, I can't really change that. But if I need a 3 here, I'm really going to multiply by 3. Because I'm multiplying by 1, I'm not changing anything, but I'm introducing the 3 on the top so I can marry in with, because I need that, don't I? And I'm going to move that 3 and they disappear. Can you see that? And then not only that, but I can take that whole 2/3 at the front. That is that, and that is my u. 1 on u du. What's the integral of 1 on u? That's interesting. Anyway, we'll get there. Log U. And what's log U? What's U?
3x plus 5.
And I? Plus C.
What's going on with that?
Because when the
So think of it this way. Well, you've got to know your patterns to start with. But if it was the integral of u to the minus 1 du, what's my pattern? It's going to be u to the minus 1 plus 1, which will be u to the 0. What happened to u? What's u to the 0? U just disappears. So can you see that it doesn't make sense? That pattern doesn't work for that.
Yeah.
So that's your trigger to go, there's something else with that. And you remember the pattern, that the derivative of log x is 1 on x. So the integral of 1 on x is log x. And that will just become second nature. But if you forget it under the pressure of the exam, if you try to apply the rule, you get a nonsense answer. So that comes back to, is your answer reasonable? And it's a trigger to think that there's something else.
But it's like x, 1 on x to the square.
1 on, yeah, yeah.